I'm John Powell. I'm the owner of Unlimited Automation. My forte is designing one-off systems. This is no exception here. This is a filter system designed to filter seawater for a fish farm down in Australia. We're going to look at the overall structure of this design and talk about its functionality. The system is comprised of two conveyor systems. The overall length of each of these systems is about 26 feet. They're 40 3/8 inches wide. The belt on them is 36 inches with a 6mm mesh. These are designed so that the belts on the lower section ride on these plastic water seals. The two conveyors will be mounted and set side by side so as to form a uniform seal across the channel that the seawater comes through. The seawater then has to go through the screen in order to proceed down the channel to the pumping station. Each of these units is designed out of 6 sections. These are stainless steel welded fabrications. Each of these 6 sections is identical in terms of its fabrication, so technically it can be used at any point along the conveyor system. However, once we populate it, then it becomes more specific. For instance, here we have the tail roller here, and that's mounted on here, will be shipped that way. The lower sections have 6 idler rollers in here. Those idler rollers support the screen so that the force of the water is maintained by those rollers. As we move up out of the bottom 3 sections, we move into the top. We then go to 4 rollers each, since we do not have the load on that. The only load we'll have then is the stuff that they're filtering out of the seawater. The upper end contains the drive roll. This drive roll is a little novel. It has a standard motor gearbox, DC motor gearbox drive on it, so it's variable speed. It can go from a few inches per second up to probably 25-30 inches per second. But in addition to that, I've designed in a rotary head that allows minor adjustments of the tracking of the belt, and then the extension system in here moves the head forward and backward to tighten and loosen the belt for various purposes, installation and operation. Both of the rotation and the extension are controlled by those stepper motor gearboxes that you see there, the little ones, and then the other motor gearbox is the drive system. When these are assembled, the two belts will be moved close. They'll be mounted side by side. We have holes here in the midpoint of each of the frames, which we will put bolts through to fasten these together to form a complete unified filter system. This system will spend its entire life immersed in seawater, and seawater is terribly corrosive on almost any kind of metal. So corrosion control has been a major concern in the design of this system. Here's what we've done to minimize corrosion. First of all nuts and bolts are stainless steel. All of the framework is also stainless steel, mostly 304 with a little bit of 316 in it. The rollers, the idler rollers, are a custom design. They're made from Schedule 80 PVC with PVC plugs on them. The mandrels that they roll on are made from a marine grade brass, both a bushing and a rod. And then the mounts for the rollers are made out of aluminum. They're 6061, but they have been coated with a plastic coating to minimize their corrosion exposure. The other thing we have done in the design on this is to put in magnesium anodes. Zinc is the preferred material for seawater application. Magnesium is not. But since this is going into a fishing operation or a fish farming operation, zinc is poisonous to fish, and they've asked to use magnesium. So we've used a magnesium shaft anode here, extension of the shaft for the roller. The reason this one has its separate magnesium anode is because it's mounted in a plastic bearing with stainless steel ball bearings in here. That leaves this electrically isolated from the rest of the system, so it needs to have its own anode. And if you can come around over here a bit, I'll show you what we've done on the frame here. This is fairly small, but this is a magnesium anode that's designed to go on to rudders of boats. In fact, all of this stuff comes out of the boating industry. The other thing that was done is the entire frame was coated with an epoxy primer that's designed for boating applications, both above and below the water. It's very seawater resistant. So we've done that to minimize the bare metal surface that this anode has to protect. I don't know how long these will last. That will have to be experimentally determined in the field. The nuts and bolts on here, as I said, are stainless. This is a 1/2 inch here, which is used only for fixturing purposes here. The bolts that are being provided for this are 3/4 inch, and there are 2 per section here. One is adequate for strength, but if you want to match the strength of the angle iron frame here, then you need to be slightly over the 3/4 inch bolt, so there are 2 holes here. But probably the best thing to do in the field will be to use 1 bolt, as long as the frame is properly supported at this end. This will be the end that's in the seawater, and then the other end that's up in the air where the material that is being filtered out will be dropped off. But I would support that, the second frame back from the motorized head frame up there. This is the control box. There are 2 of them, 1 for each unit. In here we have some power supplies, we have some stepper motor drivers, we have a small Arduino style microprocessor down under there, which I have loaded programs into to operate the 2 stepper motors. This is the DC drive mechanism for the main drive motor. There are 4 buttons here which will be labeled before we ship this out, but 2 of these buttons rotate the head of the drive roll, and the other 2 extend and retract the drive roll. When you receive the unit, it will be mostly in the retracted position. Now, a caution here: normally with motion systems, you like to have limit switches which limit the travel. We do not have that on the extension, so one will want to pay attention that you do not overdrive the extension one way or the other. With the belt on there, you can't overdrive it. You'll over torque the belt. But at any rate, you will use these 2 buttons here to retract the head and extend the head to tighten the belt once the belt is installed. Okay, now we're going to talk a little bit about the belt installation. The belt will come rolled up on a cylinder, and it has what they call an alligator type joint on it. We're going to take a look at that over here. We've got it exposed up on top here. But if you look very carefully, what you'll see is loops at the end of the fabric on both ends of the belt. These loops are designed so that you can push them together and run a wire down between them so that the 2 then become sewn together with the wire. And you want to be very careful when you do this that you alternate loops one side the other so that you do not create a distortion in there or a weak point in the belt. The wire we're using here is a little heavy gauge. It's some temporary wire I used that I had here in the shop. But we're sending wire that was shipped with the belts from China. It's a little lighter gauge wire. It's a little easier to work with than this. And when you bring the wire out on the end like we have done here, it's light enough gauge you can then weave it back into the one side of the loops here to make it secure so that it doesn't drag or come loose. But that's the technique for fastening this belt. To do that, you need to have the head fully retracted, or at least mostly retracted, so that you have plenty of slack to work with. Once you've got it sewn together with the wire, then you can go out and extend the roller until you tighten the belt to what looks to be an adequate tension on the belt itself. We do want the belt to lay flat on the water seals here, and the rollers underneath there will carry the weight and the load of the seawater going through the screen, and also of the debris that's catching on there. Looking down in the box, this belt has been adjusted so that it's tracking very well. So we're going to just turn the belt on and let it run so you can see the motion of it here. Okay. We have a speed control here. We can take the speed way down. Up to a fairly high speed. Probably about the speed they'll operate it at. It is a filter. We're going to talk about the installation of this, mostly about the packing and unpacking of the system. Both systems have been tuned to make the belts track on these particular frames in this particular configuration. So in order to redo this configuration in the field, we will put numbers and letters down here on the frame so that the joints match. For instance, this might be right number R4, R4. So we will put the same number on both sides of the joint. That way you can line those up and match those up during the installation process. We're going to pack 3 frames per crate. The larger crate will carry the front frame with the drive roll system intact. We will not disassemble that. And we will pack some foam on top of this so that we can then stack the tail roller, which also is a little longer than the standard midsection sections here. And so it will be stacked next, and then we will stack the second section back from the drive roll on top of that, and that will form one crate. That crate will be roughly 60 inches long, 48 inches wide, and about 48 inches tall. The other 3 frames that form a conveyor will be packed in a separate crate. They will be, they're essentially 4 feet in length, so we'll be able to pack those in a 4x4x4 crate. And they will again be foam packed, also numbered. Now, one of the cautions that you need to take when you unpack this and you're handling these, do not handle them by the PVC rollers. Use only some attachment to the frames themselves to lift them, conveyor them into place, or to crane them into place, or however it is you're going to assemble them in the field. But handle all the weight always on the frames. Same is true for this drive roll system. Do not pick up the drive roll system using the aluminum structure up here. Use the frame that it's attached to. Yes, I certainly appreciate the opportunity to design and build this structure for Humpty Doo Barramundi, and we certainly appreciate the opportunity to work with you. So thank you very much. This is John Powell with Unlimited Automation.